I want to hit some main points for Friday because we didn't record on Friday. We talked about squaring numbers. That means to the second power. And so the first thing I want to talk about is pretty much some vocabulary. If you'll look here. Okay, these are the things that I want you to definitely get, especially if you were not on Friday. We did not record on Friday. So we're going to begin to talk about exponents, and you can either copy this down or just snap a picture of it real quick. But I want you to know that if you have something to a power, we call this an exponent, okay? This we call the base. Now the exponent tells us how many times the base is going to be multiplied by itself. So I wrote it down here, x, and we call this cubed. You can say x to the third power, or you can say x cubed, C-U-B-E-D, cubed. And this simply means write the base down 3 times and multiply it. That's what it means. Okay, now the place where people usually get mixed up is when we use actual numbers and they say 3 to the 4th, and it looks to them like that might be 12. Okay, you need to be very careful about this because it is not 12. It says write the base down 4 times and multiply those together. When you do that, you get 81. Okay? 3 to the 4th power is equal to 81. Now, when we talk about this, one of your worksheets will ask you to put numbers in exponential form, expanded form, where you write it out. And if it's not a variable and you can actually do the math, then standard form would be the actual answer. Okay, and there is a worksheet that you're going to be doing that on. Now, one last thing that I didn't put on here, but I'm going to do that right now, is how to do this on your calculator.
Good morning.
Good morning, Sherry. I apologize about you having a hard time getting in.
It's okay.
All right, there is a button on your calculator. And to do 3 to the 4th power on your calculator, you can use this button. It's on the left-hand side of your calculator. We call it a carrot top, but when you put it in, I like to call it 3 to the power of 4. The same here, 3 to the power of 4. This is to the power of, and this gives you the options of taking a base to the power of any power. You can go to the 7th power or the 2nd power or the 13th power, okay? This creates an exponent, and you'll see that on your screen. I'll show you exactly what this looks like. I've put 3 on there, and the carrot top is right here underneath the pi button. So when I push that, it puts a block up there where the exponent should go. Now I type a 4 in, and here it is. Now, one thing you need to remember about using your calculator is if you don't space over Then the next thing you type, we'll still type it in the exponents and it'll try to do it as an exponent. If you wanted a plus something else, it would mess up your answer. So you need to move over and get it out of there before you do anything else to this problem. And when we press enter, you'll see the 81. Okay, this button right here is, we call it a carrot top, and it's to the power of, okay? Now, the very first pages in that packet were telling you to square things. It was dealing with things going to the second power. And there were a couple of things that I want to make sure that you're aware of when you're trying to do squared. Squared is the little 2, okay? The little exponent 2, which would look like, not the little face, but here. The exponent 2, we call it squared. Squared. Okay, so here's the first thing that I want you to know. Very, very important, and it will save you a lot of time, okay? Anything that you square, if it says 4 squared or -3 squared or 17 squared, anything to the second power will give you a positive answer. I know some of you have a terrible time about negatives and positives. So if you can remember, if it's a number squared, it will give you a positive answer. Okay? Now, the next thing that's extremely important and causes a lot of confusion with students is here. See how confused that guy is? He's really confused. And he saw it outside snowing. Okay. This one says be very, very careful, okay? Because especially when you're squaring a negative -3 in parentheses squared will give you a +9. A negative number not in parentheses will give you a -9. And this is the mistake most students make when they try to stick the numbers in the calculator and they forget parentheses. Now, here's the reason why this happens. The calculator does all of the order of operations the way that we learned them. And we learned them because that's the way the calculator does them. Now, when we do a -3 in parentheses squared, that is telling the calculator, notice how the 2, this is how I think about it. Notice how the 2 is touching the parentheses. It's not touching the 3, it's touching the whole parentheses. So it's saying, take the entire parentheses, which is -3, and write it down twice. And write it down twice and multiply it. So this becomes -3 times -3. Well, we know that a negative times a negative gives us a positive. And so when we have -3 times -3, it will indeed give us a +9. And that stands with what we said. Anything squared is going to give us a positive number. So what is happening here? If you'll notice, the 2 now is only touching the 3. Okay, this is the only way I can remember it. The squared is only touching the 3. So it tells the calculator, I want to write down 3 twice and multiply it together. So 3 times 3, that will give me 9. Then I multiply it by the negative. And that's why I get a -9 here, because the squared will only write down the base that it's touching, and it's just touching the 3. okay? And in our order of operations, if it makes any sense, we do exponents first, and the exponent's only touching the 3, so 3 times 3, we get 9. And then we're multiplying, multiply comes after the exponents, we're multiplying by the negative or -1. And that's why the negative is put on the 9 after. Do you guys kind of see the difference here? So the bottom line here is definitely if you're squaring a negative number, you have to put it in parentheses if you are going to put it in the calculator, or you will come up with the wrong answer. So be very, very careful when squaring a negative. Okay, point taken. I'm hearing muted yeses. Correct? Okay.
Miss Dara, can you hold
Yes.
your paper back up for the top? I didn't get the top written down. I was trying to get my screen bigger and I missed it.
Okay.
What the positives? Oh.
Did you get it?
I'm getting it.
Okay.
So any negative, like you just showed us is we'll always need to put it in parentheses.
Yes.
So
Yes,
what
you
if
do.
it doesn't have a negative, but it's we don't have to put it in parentheses because it would be a positive?
I think that's safe to say. If you're squaring a positive number, the parentheses aren't as important. Okay.
Okay.
Now, if what I usually teach my tutor students is if you just want to be safe and not try to think about when to use parentheses and when not, better safe than sorry, put it in parentheses. Okay.
Yeah.
And it will always be right if you put it in parentheses. They're
Okay.
not necessarily needed on a positive, but you might as well just get used to putting them all in a parentheses, okay? That'll be safe.
Okay.
Good question, Brandy. Very good question. Okay, we're going to start today. Before we do, here's the worksheet, and it wants you to practice squaring numbers. Down here on the bottom, it says find the squares of the following numerals. Here's a -31. They want you to know to put that in parentheses, okay?
Mhm.
They want you to know to put these in parentheses, okay? So remember that. Then the next one looks fine. You can do that. All right, here's what we're going to start today. We're going to do exponents, the product rule. Product is the answer to a multiplication problem. So what they're doing is they're going to tell us the rule for multiplying same bases. Now, if you'll remember, I want to go back to the first page. You'll have this to refer to. Product. Here's our rule right here. Product of powers. Let me get it on the screen. Okay.
Mhm.
Notice that the x and the x here are multiplied. The x is same bases. You can only use this rule when the bases are the same. If the bases are the same and they're being multiplied, then you simply add the exponents. Okay? Here's another example over here. Can't read it. There we are. Okay. And you'll still have to know about your negative and positive rules. But over here, here's another example that says x's are the same bases and they're being multiplied. And so you just add the exponents. This is adding to. So the answer is x to the -5th. So let's take that rule to your worksheets. Oh, I want to show you something. Let me do this. I want to show you why this is the rule. Because if you have x squared times x to the 5th, this is the same Okay, here is the reason why this exponent rule works. Because x squared is the same as x times x, true? The base times itself twice. And this base times itself 5 times, 1, 2, 3, 4, 5. And the multiply in between makes this entire thing x to the 7th. Do you see? This is why this rule applies. So they gave you a shortcut and they said if the bases are the same and they're multiplied, simply add the exponents. And this is why it works. So let's go to your first worksheet. And I have it sort of in order. So the first one I want to look at is this one.
Product rules.
Okay. It says exponents product rule. And this is the first problem right here. Number 1. For those of you who don't have a worksheet. Did all of you find that worksheet? Now, if you'll notice here, the bases are the same and they're being multiplied together. So our rule of exponents for multiplying same bases simply says, I'm going to take k and I'm going to write it down here. And when I add a -1 plus 6, that will be the new answer exponent. So your answer to number 1 should be k to the 5th. K to the 5th. I'll do this. This is what's happening. I'm going to use the same base because they're the same. And I'm going to add the exponents, -1 plus 6. And then all you need to do is remember your rules for adding negatives. And that will give you k to the 5th for this answer. Is it pretty clear, y'all? Brandy?
No, I'm confused.
Okay.
I can't find my sheet. I'm pretty sure I printed it out, but I'm not finding it.
That's okay. I'm recording this and you can go back if you would like.
Okay.
Okay, let's look at number 4 because that happens to be on my screen right now. The big numbers are the bases. And in order to use this rule, your bases have to be the same. So my A's are the same, so my answer will be an A.
Okay.
Then, because they're being multiplied, I only have to add the exponents. Okay, anybody with a calculator, or if you remember your negative rules, what's -3 plus -5?
+8.
Now, the two negatives, when you're just simply adding them, stay negatives. That just means we've got a pile.
Oh, yeah, that's right.
Okay, so I have an A to the -8. You see why?
Yes.
It's because I'm simply adding the exponents. That's all you're going to have to do on this page. Even number 3, that looks horrible because it's got fractions. You don't have to worry about that because the C over D is simply the base. So what's happening here is C over D to the 9 plus 0. And so your answer here's what's happening. You simply write down the base, then add the exponents, and then the answer is the base and what you got when you added the exponents. Okay, don't try to make this harder than it is. As long as the bases are the same, that's the base that's going to be in the answer. I just want you to learn that you add the exponents together, okay? Now let's go down here. Brandy, are you getting any clearer? Are you
Yeah, yeah.
okay. Now the second part should not confuse you, but it might because it's the first time you've ever seen it. It says find the value of X. Now they've made this into an equation here, but notice if you covered up the answer, okay, you would know that my answer is going to be negative 12 to the power of negative 1 plus X. Is that right? I would use the base the same as it is and add the exponents, right? But in this case, the X, well, I have a variable there. So what I need to do, if they said, okay, here's your answer, then that should tell me that negative 1 plus X equals negative 16. So what you need to do here then, all I need to worry about right now is the exponents. So I should have negative 1 plus X has to equal a negative 16. Do y'all see? And then we're simply going to solve this equation by adding 1 to both sides. I'm going to add 1 to both sides. This is our normal. So when I simply solve the equation, I'm going to add 1 to both sides. Do you see? I want the X by itself. It was a negative 1. I'm going to add 1, so I have to do the same thing to the other side. The negative is bigger. I think subtract. So I get a negative 15 for X. X equals negative 15. That's all they want to know is what is the value of X. Is this making any sense? I hope so. I know that you guys have muted on purpose for me. You should be able to answer the bottom. Think about it and remember to text to me if you get stuck. Let's go the next page that says exponents product rule is exactly the same with different numbers to practice. This is the one that says, up at the top, it says T1S1. Probably should have been the first one, but they're the same. I want to go over one more rule with you, and then I want you to go practice before you forget them. Okay? Now, just think about it, okay? Just think. If I'm multiplying same bases, then my rule was to add the exponents, right? What if I'm dividing same bases? What should I do with the exponents now? If I'm dividing, Sandra? I can't hear you. You need to.
Multiply?
Actually not. What's the opposite of add?
Subtracting.
Okay, so if we're multiplying same bases, we're going to add. If we're dividing same bases, we're going to subtract. And that's all the rules we're going to do today, so I don't mess you up. But if you want to look, it is the one called quotient. Quotient is the answer to a division problem. That's why this is the rule. Okay? Now, what the rule says is if I'm dividing same bases, then let's ignore this one for right now, because that will confuse you. Okay, we're going to do that a little bit later. All I want you to do this time is if you're dividing same bases, I want you to subtract the exponents. So let's look over here. I don't know why they're using a bunch of negative numbers. That's crazy. Okay, so here's an example. It says, here are same bases and they're being divided. So we know the rule is to subtract the bases. So you're going to have -7 minus a -5. So your answer is going to be x to the second. You're going to subtract exponents. So let's look at this. Let's look at your quotient paper, and I think I gave you 2 of those also. Here we go. This is the one that says T1S1, the quotient rule. Quotient is the answer to a division problem. That's why they're saying the quotient rule. So look at number 1. If you notice, the bases are exactly the same, okay? Which means I don't cancel those out. I simply know to write -5 down here in parentheses because it's negative. And then I simply subtract the exponents, 17 minus 7. So my answer is going to be the base, -5 in parentheses, to the 10th power, -5 to the 10th power. Now I want to show you why this works, just like I showed you the multiplication. Let's do x to the, let's do 7th divided by x to the 4th. I'm going to do this for an example. See it? So the reason that this works as a shortcut is because here's what's happening. X times X times X times X times X times X times X. 1, 2, 3, 4, 5, 6, 7. On the bottom is X times X times X times X. Okay, this is what X to the 7th over X to the 4th means. X times itself 7 times on top. X times itself on the bottom 4 times. But if you notice, if there is an X on top and an X on bottom, they will cancel each other out to ones, which leaves what?
3.
X to the 3rd on top. Do you see? 7 minus 4, they gave you the shortcut, especially when you're going to use 17 minus 22, okay? So you don't want to write 17 x's and do this every time, but this is what's happening. You had 7 x's on top and 4 on the bottom. Let's cancel what we can, and you're left with 7 to the 3rd. They give you the shortcut. 7 minus 4 is 3. X to the 3rd. Okay, so let's look again. Again, we're going to do exactly the same thing. Don't let the fractions bother you here. 2/3 divided by, so it's a division. They didn't put it on top of each other, but these are the same bases, and so that's going to be in your answer. And then you're going to take 0 minus a -8. So I want to point this out to you because sometimes students get confused here. So here's what it should look like. Since this is a division, then we know we're going to subtract the exponents. So I say 0 minus a -18, okay? But we found out when there's a minus and a negative together, they become a plus sign. And so your answer is going to have the same base, and then the answer to what you get when you subtract the exponents. If you subtract a negative, you're going to end up with a positive. It's all brand new, I know. But what is cool about these rules that you're dealing with is that these are the shortcuts that they're giving you. So you don't have to do it the long way. Okay? So although it's brand new and a little bit earth-shaking, just understand that you just need to work at it. These are good shortcut rules for you. That's why I'm not going to give you all the rules today. So for what I've given you, you should be able to do all of the worksheets in the packet that started with this. I think it was packet 2. Let's see, you had 1. Yeah, this might just be packet 1. I don't have the numbers written on mine, but it's the one that started with this, okay? It's this packet. You should be able to go all the way through. It talks about squares. It talks about expanded notation. And then it talks about the exponent rules for product, the exponent rules for quotient. Don't go on to the product rule, the exponent rule for, oh dear, out of order again. Hang on. There's all those and those. If it has any more rules, you guys, I might not have, no, I didn't print that far. If it has any more rules, wait until tomorrow. I have no idea what the weather tomorrow will bring, so be sure and watch. I'll try to put something on email and something on text, and I will go ahead and send you the Zoom invite by email today. I will do that today. It will come like it always does in email. Is it easier for you guys to go ahead and get on at 8:45 if we're out for the weather? Or is it easier for you guys with children to wait until 10 for the Zoom? Which one? Speak up. Anybody?
Doesn't matter to me.
Okay.
8:45 is good for me too.
8:45 is better. Brandy, do you think 8:45 would be okay?
Yeah.
Okay, now I know, I think it's an hour earlier for you, Sherry, is that correct?
Yes, but it's fine though.
Okay, well, I'm gonna send you I'm gonna send you a Zoom for 8:45 for tomorrow morning. So the only difference with the weather will be whether all of you come on Zoom or the in-face people come into the classroom. You'll just have to watch the weather and watch our notices for you, okay? But no matter what, the Zoom will be at 8:45. Sound good?
Yes.
Yes, ma'am.
Do you have any questions right now, or do you feel like the questions will come up when you start practicing?
Both ways.
Okay, Sandra?
I think I'm good for now.
Okay. Sherry?
I think I'm okay.
Okay, Luanny?
I'm good.
Okay, Brandy, I want you to text me, or even if you need like a one-on-one Zoom to help you again after you look at the YouTube again and try to practice. If you're still confused, you let me know.
Okay.
We'll take care of it, okay?
Okay.
Okay, you guys are wonderful. Please stay warm and safe, okay? And
Thank
we'll
you.
let you know what happens tomorrow, okay?
Okay.
Okay.
Love you guys bunches.
Love you too.
Okay, bye, Miss Hall.